Alex, we are ready
No?
to start. We have got 34 participants.
All
Go.
right. I was waiting for Hedy, but I'll start now.
Yes, it is Gerdy speaking now.
Oh, all right. Should I start?
You can start.
All right. Good afternoon. Welcome to today's Natural Science Grade 7 class. My name is Mr. Alex Songo. I am going to be your natural science teacher throughout this period. All right. Prior to us starting, ladies and gentlemen, yesterday we looked at a couple of aspects related to term 2 content. I just want us to look at the corrections in relation to what we spoke about yesterday. So just to go through some corrections of the activity that we gave people. All right. We asked you to go and investigate the different types of materials as well as their physical properties. And we spoke about this yesterday. We said physical properties are how a material behaves. So basically that speaks to how a material is strong, if it is, if it's got any form of flexibility, if boiling happens, does it melt, is it heat conductible, or is it electrical in terms of how it behaves itself? So basically that's what physical properties are. So we had 5 examples there, and that's what we actually spoke about. So I just want us to look at the gate. Excuse me, ladies and gentlemen. So the gate definitely has got strength. And if we think about it, the gate has got strength. Why? Because the gate is made up of steel. And as we know, the steel that is found on our window frames in our homes or our rooms is very difficult to break into. You need to get to either cut it or use some form of other very strong mechanism to be able to break that, or rather even bend it for that notion. Flexibility, absolutely not. Hence, I'm saying it's very difficult to even bend it. So definitely it's not flexible. Does it boil? Not. Does it melt? Not. Is it a conductor of heat? Definitely it's a conductor of heat. If right now there's the sun in whatever area you are and you have a steel gate in your home and you go and you touch that steel gate, because of the sun rays that heat that steel gate, you'll find that it's heat conductible. What does it mean? It's actually quite hot right now. So definitely it is. And if it's heat conductible, like I alluded yesterday, I said heat conductivity is almost always intertwined with electrical conductivity. So also, that's one of the things that we need to think about when we talk about the gate. The second part is an elastic band. Now, is an elastic band strong? No, it's definitely not. So we don't tick on that. Is it flexible? Absolutely. Hence the word elastic. It's able to stretch to whatever length that you might stretch into, but of course it will break at some point. Does it boil? No. Does it melt? If it's given a high intensity of heat or there's an increase in temperature, definitely it's going to do what? It is going to melt. So if you take an elastic band, remember it's made up of plastic. You put it on top of a hot stove. We are not saying that's what you should do, but we're just using this for purposes of understanding so that you know what it is that we're talking about. It will definitely melt. Is it heat conductible? No, it's definitely not. We go to the wooden desk. The wooden desk is a very, very familiar type of a resource that we find in our school environments. Now, the wooden desk is strong. Yes, it's quite strong. Remember, wood comes from trees. In our next lesson, it's actually very interesting because we'll actually speak about that. But nevertheless, so wood is actually very strong. That's why we can put whatever, when we are writing, we can put our hands, we can actually even go as far as putting our heads against the wood. It's very, very strong. Is it flexible? Definitely not. Why? Because it's strong. Can you see what's going on here? If something has got strength in how it is, the flexibility of that item or of that item or property is therefore, what is the weight affected? So the stronger something is, the less flexible it is. Does it boil? No. Does it melt? No, it does not melt, ladies and gentlemen. All right, we go to water. Is water strong? No, it's not. Is water flexible? No, it's not. However, obviously, if we speak about the properties of water in terms of the flow that is there, we might speak about water being flexible, but that's not the context in which we're speaking about water. Does water boil? If you remember from the previous lesson, we had examples where water was being boiled using a stove and, of course, using a pot, stainless steel material. So yes, it definitely does. Of course, water melts. How does water melt? It melts if it's found in a solid form. The solid form, again, the ice cube that we find in our fridges. If you take an ice cube, you put it outside your pavement right now, if the sun is still out, you will realize, and even if the sun is not out, because you've taken out the coldness and therefore you've decreased the coldness of that ice cube and you've increased what? The heat, that water is going to start to melt. The last part is the plastic chair. Most of us, or some of us, might be sitting in one right now as we are learning. So a plastic chair is also a very good example of something that has got a lot of strength. And in the next lesson, we are going to talk about plastic chairs in terms of how the material, rather, in which they're made of. Remember, our next lesson is on the environmental impact of materials. Is a plastic chair flexible? No. If you try to stretch it right now, you're not going to succeed. Can you boil it? No, you cannot. Can you melt it? No, you can't. Is it a good conductor of heat? Definitely. If you sit long enough in a plastic chair, when you stand up and you touch where you were seated, you will realize that there is some form of heat. So again, you realize that it is heat conductible. However, it is not electrical in terms of how it is. Remember, at first I said, sometimes in most instances, conductivity of heat is related to electrical conductivity, but not all the time. Ladies and gentlemen, so those were our responses from the previous activity, which was yesterday. I just want to have a look at the chats to see maybe if there are any questions related to that. All right. But thank you so much to everyone that's logged in. I just want to have a look. Oh, I see Charles Chaukere. He's asking if we can be able to unmute everyone. Unfortunately, not now, Charles, because I have to speak through the lessons. But if you've got a question, please definitely, please definitely ask, type the question. I'll definitely respond. Oh, Thomas is also there. He cannot hear. Sorry about that, Thomas. Is it true that your hair is 3D printing of your hair? That's Onika Moyo. Not sure who that question is directed to, but a very funny question nevertheless. Ladies and gentlemen, remember when we respond to this, we are asking you to please hashtag lockdown eSchool in all your answers on all your social media platforms so that we can be able to be found and anyone that wants to speak to us can be able to also use this platform. Now, what is it that we're doing today, ladies and gentlemen? Let's go. Lesson objectives. So this is, what is it that needs to happen before the end of this lesson? What must you have learned? The first thing is when we talk about raw materials, what are we talking about? We then speak about greenhouse gases. This has been a buzzword for a very, very long time, but with very little understanding. So this is the point of this lesson. Then we've got the third objective of this lesson, which is the polymer. When we speak about that, what is it that we're speaking about? Then we speak about biodegradable. So again there, what is it that we're going to talk about? So those are our 4 lesson objectives. Number 1, raw materials. What are we talking about? Number 2, greenhouse gases. Number 3, polymers or polymer. What is it that we're speaking to? And number 3, biodegradable. Let's move along. So now, as we are speaking about this, I want us to ask ourselves, number 1, can you give me any example of a raw material that you know? Any example? Some of which you might actually see if you look through the window, outside the window. There's one that is actually commonly found. What is that? Think about it. With raw and material, what does that mean? Remember, we spoke about materials in the previous lesson. Number 2, when we speak about greenhouse gases, what are we talking about? Obviously, these are gases. But what does the word greenhouse mean? So again, we are just tying these questions to probe our thinking so that we can understand what we're actually talking about. Number 3, is this the first time you've ever heard the word polymer, or you've heard this word before? Where did you hear it? What was it associated with? Or are we actually going to learn that today? Number 3, define or explain the word biodegradable. What is meant by biodegradable? Ladies and gentlemen, that's the purpose of this lesson. That's what we seek to actually understand throughout this lesson. So Going right along. Raw materials. What do we mean by raw materials, ladies and gentlemen? So raw materials are all the natural unprocessed materials that we have on earth that assist us to make materials. So everything on earth that is unprocessed, that assists us so that we can be able to make other materials, is a raw material. I've made an example there, ladies and gentlemen. The example that I've made is the example of wood. You'll remember that when we were speaking about us actually investigating your various materials in line with whether or not they are their physical properties. I spoke about the wood that we find on our desks at school, and we're investigating that. And I said, we'll speak about that now. So that's what we are speaking about. So wood is an example of a raw material because wood comes from trees, right? So what is the raw material there? It's a tree, ladies and gentlemen. So the tree is a raw material. It's unprocessed. What does the word process means? It means it's unaltered. Nothing has happened to it. If you cut down a tree right now, of course, we don't advise because of greenhouse gases. We will get to that. But now, if you cut down a tree, you will realize that it's as raw as it is. It's natural, it's nature, nothing has happened to it. So we then use wood to make paper. Ladies and gentlemen, there's a picture there. In the picture, I'm trying to move my cursor. So there's the tree that's being cut down, right? Now, when the tree is being cut down, water is added onto the tree. Then we boil the wood to make it pulp. After that, there are chemicals or dyes that are added. Remember, wood is usually what color? Brown. So how is it that then wood moves or changes to the color white? So that's what we are speaking about. So therefore, there are chemicals that are added that assist us, or dyes, to create whatever color. So when those colors are created, what then happens? Pulp is poured, and then the fine mesh is then squeezed through the rollers to do what? To create paper, to create tissue paper. So ladies and gentlemen, so now we see wood is a raw material that is used to create another material. What is that material? It's definitely paper. Paper that we use in our classrooms all the time. When we write tests, when we write exams, when we write assignments, we use that as well. Also, like I've alluded, also in the toilet. However, ladies and gentlemen, there is a very sad, unfortunate reality. Because raw materials are natural, so no one makes these things, they are actually created by nature, right? The reality is each and every time we process a raw material, there is an impact that happens to the environment because raw materials come from the environment. So each and every time we process raw materials or we cut a tree, there is a certain effect that is then happening directly to the environment. And that is what I want us to actually look at today, the impact that these have on our environment. Let me just look at the charts again and see. Definitely, Zanda, you are correct. The